In this video, we'll be looking at how you can attack a real Kubernetes cluster and some of the things that you can do to protect yourself against these attacks. Along with this, we're going to be looking at a lab from AppSecEngineer that you can use to actually see how you can perform some of these attacks. So we'll be going right from compromising an existing web application to being able to get complete access to a Kubernetes cluster. So we'll look at the entire attack sequence and figure out how the attack works. And through the attack sequence, I'm going to talk you through how you can protect yourself from these kind of attacks. Let's get started, and let's get started now. One of the most common ways in which a Kubernetes cluster is attacked is when you have a pod that is deployed inside Kubernetes. Let's say you have some kind of an application that is deployed inside a Kubernetes cluster. Now, this application may be vulnerable to a host of things. So let's say it's vulnerable to some SSRF issue or some other kind of issue that leads to a remote code execution. Now, when this happens, the attacker is able to access, let's say, the runtime environment of that particular pod or container. Now, inside that container is usually a service account token. And once the attacker is able to identify the service account token, the attacker is able to potentially leverage the service account token to expand privilege and gain access to the Kubernetes cluster. The service account token essentially is a token that is mounted into every single Kubernetes container that's inside Kubernetes. And because of this, the attacker may be able to leverage the service account token to be able to expand privileges into the Kubernetes cluster. Now, this tends to happen with certain scenarios, and of course, it's not always the case, but when you do get access to a service account token, more often than not, I find that a lot of service account tokens are associated with privileges that are extremely high on the cluster. And once these high privilege service account tokens are compromised, you typically see that it can lead to an expansion of compromise when it comes to a Kubernetes cluster. So you can do things like privilege escalation, you can do exfiltration, you can do a whole persistence, you can do a whole bunch of things inside the cluster with that. So I'm going to do this with a small whiteboard diagram, as well as, of course, do a demo on how this actually works. Based on the Kubernetes spec itself. Now, Kubernetes really has two kinds of users. There's one, of course, you who is the human user, and the other is basically machine-to-machine communication, right? If you want an API to talk to Kubernetes, or if you want one of your pods to talk inside Kubernetes itself, you have something called the service account. Now, service account is a very common concept that is there not only in Kubernetes, but in several other computing environments. So you'll see it on the cloud, you'll see service accounts on the cloud, you'll see service accounts in Linux, you'll see service accounts in all over the place. Service accounts essentially, as the name suggests, are for other services to be able to access a particular environment or a particular runtime environment. So in the case of Kubernetes, most of it is really around the service account, right? Especially because the service account becomes very important for an attacker to compromise a particular Kubernetes service. So for instance, if an attacker wants to attack or compromise Kubernetes cluster, most of the time they want these credentials. And these credentials are usually inside a pod. Most of the time, the way it works is that you have the pod here, and these credentials are mounted inside the pod. Now, Kubernetes by default mounts a service account token into the pod. So if you don't give it any specific service account name, so Kubernetes mounts the default for that namespace inside that particular pod, and that's how it works. But you can, of course, create your own service account, give it a specific set of RBAC privileges and so on, and then mount it if you need to. If you don't need to, I recommend not mounting the service account token at all. You do have a configuration parameter that allows you to not mount the service account token at all. So let's say your application is just another web application that is just behaving like a regular web application and is not talking to anything within the Kubernetes cluster, then you really don't need to mount the service account token. There is no reason to mount it. However, if you do mount it, then make sure that you create your own service account and of course assign certain privileges to it. By default, the default service account token does not have too many privileges. It does not have privileges, which is a good thing. But a lot of times you will see that the services that are deploying them come up, people create these service accounts and they give them a lot of privilege. right? So let's look at what can happen. So in a Kubernetes cluster, you're looking at a service account, which is something that we've explored so far. What happens is that it's mounted on the file system. It's mounted within a path inside the Kubernetes, inside the pod, inside a particular container. In every container in the pod, the service account token is mounted. So if a user is able to get to this service account token, then it's basically the user has, or the attacker has, the ability to escalate privileges and do other things with it. Now it all depends on what kind of privileges this service account token has. So let's say the service account privilege has a cluster role, right? And this cluster role is a highly privileged role. You can do all bunch of stuff on the cluster, then you have a huge problem. Simply because cluster role, as the name suggests, is scoped to the entire cluster, and this service account can do things entirely on the cluster, which means I can get secrets, I can get pods, I can get deployments, I can even roll out my own deployments perhaps. So it really depends on what kind of privileges this cluster role has. Now, even if the service account has just a role and a role binding, it really depends on what kind of a privilege that role has. Now, a role, remember, is restricted to a particular namespace. So within a namespace, there exists a role, and that, of course, that role is scoped to that namespace. But let's say that role has a lot of privileges within this namespace, and that namespace happens to be, let's say, prod. Then you have a bigger problem, because now you have the token that has a lot of privileges on this namespace, and that namespace, let's say, is a super critical namespace, and you're able to do things on that namespace. So from that point in time, it just doesn't make any sense that, oh, okay, it's not cluster role, that's fine. A lot of times people just assume that, okay, if it's not a cluster role, it's good RBAC. That is not true. Just because it's not a cluster role, it doesn't mean it's good RBAC. You need to understand what is the role required for. First of all, is this service account thing even required? Does it need to be mounted inside the container in that particular path? If it needs to be mounted, what kind of privileges does it have, right? Does it have a role, or does it have a cluster role? And even if it has one of these things, what are the privileges for that particular role? That is, again, very important. So unless you have all of these things mapped out, there is a potential for an attacker to be able to compromise the application, use that service account token that is found through the compromise. So let's say you do an SRF or some other kind of remote code execution, they get access to the service account token, use that service account token to start spinning up resources in the cluster, or add your own malicious resources to the cluster, or do whatever you want. So the idea here is that the service account is one of the most common ways where people can get access to additional privilege escalation, additional persistence, additional exfiltration based on a Kubernetes cluster, right? So this is a very important concept that you should understand. Let's get started with our demo on the Kubernetes attacks. And I'm going to use one of AppSecEngineer's many labs and playgrounds to be able to showcase this. In fact, if you are an AppSecEngineer user, you can do this as well. You can just access the attacking Kubernetes cluster playground, and you should be able to get this done. Now, we're going to be using the Kubernetes Token API Compromise Lab. And this is one of the labs that actually gives you a full-fledged perspective of how this sort of an attack happens. So this is something that you'll actually see happening quite a bit. So let's provision, and of course with AppSecEngineer you get access to the lab, and you will be able to provision an environment, and you should also be able to get that to be able to use that in order to get Kubernetes cluster up and running. So we're going to first get our Kubernetes cluster up and running. Once we're done with our Kubernetes cluster getting up and running, we're going to deploy an application. Now this application is a Node.js application that we're going to deploy on Kubernetes. This application is vulnerable to a server-side template injection flaw. Now, I'm not going to go too deep into template injection because that's beyond the scope of this video. Just know that it's a vulnerability that is in the injection class of flaws, where I can potentially not only gain access to the server side, but also escalate privileges to be able to run commands on the backend operating system. And through that, I'm going to be able to steal the Kubernetes service account token and then use that token to do whatever else I want to do. Right? That's basically what I'm going to do here. If you are a user of AppSecEngineer, you have access to all of this. You do have access to not only the labs, but also the instructions and all of that stuff. Now let's actually go ahead and open up the AppSecEngineer lab. and I'm going to move the instructions over to my other monitor. Now, if you want to look at what's happening here, you will see that most of the code is in here, and I'm just going to increase my screen resolution. So we're going to deploy the Kubernetes cluster itself. And from there, we're going to compromise the application. We're going to deploy an app. Then we're going to compromise the app. And then we're going to actually steal the service account token, which is our ultimate objective. And we can leverage the service account token to do a whole bunch of things. Now, let's actually go ahead and open up a new terminal on AppSecEngineer. And I'm going to spin up a new Kubernetes cluster. Now, this is a very simple command. This spins up a single node cluster on AppSecEngineer, and you should find that we should leverage this in order to deploy our app. So this takes approximately about 3 or 4 minutes to get done. You'll see that we are spinning up a new Kubernetes cluster. It's going to download all the necessary container images to run as part of that cluster. And once you have these container images and it generates a cluster CA and all of that stuff, we have the ability to spin up our resources on this cluster. So this is something that we're going to be able to do very soon. It takes about 3-4 minutes for this to happen. As you can see, it's almost done. We are deploying our Kubernetes cluster. We also have a network plugin deployed. All the necessary cluster role-based access control privileges are deployed. All of that stuff is done. We're just waiting for the cluster to be ready, the nodes on the cluster to be ready, so we can deploy our resources. In this case, we're going to deploy that Node.js application and then get started with the rest of it. All right, looks like our cluster is deployed. kubectl get nodes gives you the nodes ready to go. kubectl get pods on the namespace kube system. Let's see whether our kube system namespace is initialized. We have all of the stuff initialized. You can see that all the necessary pods that we need for the cluster to work, from etcd to all of the stuff, is already working. Now let's deploy our application. Right now, our application is essentially going to be, first we're going to create a service account. We're going to create a service account and generate a service account token. Okay. Now you will see that this is in here. Now this is a service account that we're generating. So we're generating a service account called cluster admin SA, which is going to be for the namespace default. But this service account token is going to be given a cluster role and cluster role binding. Now this is the mistake that a lot of people make, especially when they're deploying Kubernetes resources. A lot of these Kubernetes resources, a lot of these service accounts are configured with a lot of privilege. In this case, they're pretty much broad access to everything that you need. So I'm going to deploy this, and that's really where our problems start as far as this example is concerned. So let's deploy this, and it's going to create the service account, and of course the cluster role and the cluster role binding creates all of that stuff. Next, we're going to deploy our application. Now this is our vulnerable application, which is going to be our node application. This is vulnerable in several ways, but nothing shows up here. It's also being deployed with a different service account token. Again, this has also been given a high level of privileges. This has been given a high level of privilege. You can see that you can get access to a service account and a service account token. The resources are being given for that. So that is what we have. So the idea here is that this cluster role gives you access to star API groups and the resources that it's given access to, service account and service account token. So you'll see that our secret SA service account name is being used, right? So secret SA is what we are using here. And we also create another cluster role as far as this example is concerned. Now, this is our cluster role, which is secret role. It gives us access to create new service accounts. So that's the idea of this example, right? So you're creating a service account called secret SA, and that service account can create more service accounts. And those service accounts have a lot of privileges, right? That's basically the idea here. So we're stealing tokens. We can even forge and create our own tokens as well at this particular point in time. All right. So let's just go ahead and deploy this application to our cluster, which is obviously pretty easy to do. Deploying the app, and kubectl get pods should see that our app is going to be deploying or almost running pretty soon. I should have just done -- watch when I started. Yeah, still creating. So this is probably going to be downloading the container image and then using that to push it and deploy that container, the app, in this case, that Node.js application to the cluster. So we're just waiting for it to be running. And once it is running, we can access the application through a port forwarding and then actually get started with it. So just waiting for it to get done. It does take a little bit of time. I think it's probably because the container image has to get downloaded, and of course it needs to be running. Oh, it looks like it's running now. Let's go ahead and port forward it. So what we're going to do is we need this container image, this container to be accessible externally. And for that to work, we need to bind it to a port. We either need to create a service in Kubernetes. It could be a load balance, it could be a cluster IP or a node port. But in this case, I don't want to create a service. I'm just going to go ahead and I'm just going to do a port forwarding on port 5000. That's basically what I'm going to do. So now if I access this IP address, and the way I find the IP address in my AppSecEngineer lab is server IP, then you'll see that my server IP is this, and I can access this application on port 5000, and you'll see that my application is now deployed on port 5000. You can access it on port 5000. This is my Node.js application. This is called Appsec Bookstore. Now this application is vulnerable to a server-side template injection. Now, like I said, so server-side template injection is a flaw where you get these, I'm sure many of you would have seen these HTML templates or mail templates where server-side variables are substituted for those squiggly brace templates, and that's how you get the response with those variables filled in. Now, this is a very common use in most web applications. A lot of web applications use templating systems, especially server-side templating systems. The idea of server-side template injection is that the attacker is going to be able to influence or add some code to one of the variables or one of the inputs that the attacker is sending into the application. This is getting evaluated on the server side and then reflected to the client side. So you'll see a lot of this with error messages and code templates that essentially are concatenated, very much like SQL injection, where you have concatenated HTML templates that are framed as a string, and the attacker is able to potentially tamper with the variable or influence a variable in a way that it gets executed on the server side and then rendered and reflected back on the client side. Now, this application has a certain error page. So let us say I do a slash page name is equal to 45, and it says, should I just done slash page? It says unable to find V45. So whatever page I give, this looks like a 404, a generic 4 error page. So if I do AppSecEngineer, it says unable to find AppSecEngineer because there is no URL called AppSecEngineer. But now here, since this is being reflected on the client side, maybe there is something that I can do with this. So if I do squiggly brace 7 into 7, does it actually give me some response? It says, hey, unable to find 49. So it actually evaluates the code, which is evaluated in JavaScript on the server side, and renders the result on the client side, which means that it's actually doing code execution. Now, this is where code execution is actually happening. So you can see that if I do this, I'm able to get the result of this, which is code execution, which means that I can now do much more interesting things with this application. Now, what I'm going to do is I am going to set up another terminal, and I'm going to use a very popular tool to explore further in template injection, which is called TPL map. It's a very old tool. It's been around for a while, but it's a very useful tool. Now I'm going to use this to see whether there is template injection happening and whether we can leverage template injection to do more useful things. So in this case, if you've used SQL map, you will know that TPL map is very similar to SQL map. That's the nice thing about TPL map. It's basically an automation. It's a great automated tool to help you identify template injection. So in this case, you'll see that I'm saying, try this URL and see whether I can do template injection with this URL. And I give it, and I let it run, and it says, yeah, you definitely can. You're using the Nunjux templating system, and you can use injection in any one of these parameters. I can do all of this stuff. I can do shell command execution, bind reverse shell, file read. I can do all of that stuff. I can even do code evaluation, all of that stuff. This is great because now I can start to do a remote code execution attack and compromise the backend environment. So let's actually do that. Now what I'm going to do on my attacker machine, so remember I'm simulating what the attacker is doing. I'm going to set up a netcat listener on port 1337. and I'm going to wait for connections. Now, the idea is that I'm going to get my remote container to connect back to me so that I can start interacting with it on a shell environment. So let's actually go ahead and do this. So I'm going to say, I'm going to add to TPL map, I'm going to add a reverse shell. I'm going to say that, hey, instead of running a command and all that stuff, just give me a reverse shell on this IP address, which is my server-side IP address, which I just pasted from somewhere. I have the server-side IP address on port 1337. Now remember, my netcat listener is working on port 1337, so this should work because it will execute that code. Now TPL map automatically does that, and yeah, now I have my reverse TCP shell. So this is great. I have my reverse TCP shell. Now I can start interacting with that particular container. Now remember, I am in that particular container. So in fact, what I can do is I can access different file systems within that container, and I can find the Kubernetes token, or I can start doing other things. Now what I'm going to do in this case is I'm going to deploy kubectl. I'm going to download kubectl from an external source, and I'm going to start interacting using kubectl from this particular container. So I'm going to download kubectl so that I can actually start running kubectl commands from this particular container. Now, you will see that I have installed Kubernetes, the kubectl into the container, the compromised application container, and I'm also able to retrieve the service account token, which is mounted in this particular path. In fact, if I look at the service account token, you'll see that it's signed with RSA SHA-256. And of course, it's got some payload which has some information about which is the Kubernetes cluster, what is the pod, what is the service account name, so forth. So you'll see that I'm able to retrieve all of this information. Now, the idea here is using kubectl, I want to be able to add this as a credential. So I have the service account token. Now, what can I do with the service account token? That's the objective now. So I'm going to use this token with kubectl, and I'm going to set it as the authenticated token so that I can start talking to the Kubernetes cluster API and start doing things. So basically, I'm privilege escalating into the Kubernetes cluster at this particular point. So I'm going to create a credential called my user, and I'm going to set a Kubernetes context with this particular user token. So I can start accessing the cluster as this particular user with this particular token. So this is a service account token that I've used. So now if I check what are the different service accounts in the Kubernetes cluster, it tells me that, hey, these are the different service accounts. So you can see that without authorization, this would have never been possible, because now this service account token can be used to create other service accounts and start forging other service accounts on the Kubernetes cluster. So now all I have to do to literally start escalating privileges is create a new service account. So in this case, I'm going to create a new service account token that will give me access to the entire default namespace and write it to the temp token path. So when I do this, I'm able to, it creates a new service account token for me. And if I access this particular path, it should have created it for me. In fact, if I do echo $token, you'll see that it's created a new service account and a new service account token. So if I do kubectl get say, you'll see cluster admin SA, and I've created a new token for cluster admin SA with the namespace default, and it's written to temp token. In fact, if I just copy this token value and check out what's happening, you'll see that this is for the cluster admin SA. And now with this token of the cluster administrator, since I have the ability to control all service accounts, remember we are escalating privileges, and this service account that I compromised, the initial service account that I compromised, has the ability to manipulate other service accounts. So since it has the ability to manipulate other service accounts, I don't have to necessarily get access to pods and stuff. I can just create a new token as this service account, and from this point, I can literally start escalating privileges into the cluster. So in this case, I'm going to list all the pods in the default namespace, and it says, hey, these are all the pods in the default namespace. I can start escalating privileges to other resources within the cluster. I can start listing services, open up a new file and paste the thing and change it, because the shell has limited capabilities. I'm going to, instead of pod, I'm going to change this to services and then try it out in the shell, and it should work. Secure. This was the issue. Yeah, you'll see all the services have been listed. So from this point on, you'll see that I have complete access to the Kubernetes cluster. I have created a new token as the cluster admin, and from this point on, I can access everything as the cluster admin using that particular new forged token, newly minted token that I have as the cluster admin. I have complete access to the cluster, and I have performed a full-fledged compromise of this particular Kubernetes cluster.